Greetings, everyone. Raymond Lacoste here, and welcome to today's webinar that focuses on Cisco Diagnostics. Today, we're going to unlock 5 Cisco built-in tools. Hopefully, none of you have ever heard of any of these tools, but if you have, that's okay. I'll show you a demonstration. So specifically today, we are going to demo. That is what we're going to do. Almost all of these. We'll look at SPAN, RSPAN, ERSPAN, embedded packet capture, NetFlow, embedded event manager, as well as IP service level agreement. So first question I have for everybody. So if you haven't joined the chat area, please chat in ASAP, or join the chat ASAP, I should say, so you can chat along with us. But I want to know which of these you are not familiar with, or which of these you have not used. So I'd like to know which of these are new to most of you. That's what I would like to know before we begin this particular discussion. So if it's all of the above, type in all of the above. If you've never heard of EPC, type in EPC, or EEM, type in EEM, right? So these are some really cool features that are built in. That's right, they're built into our Cisco iOS products. Now, typically, we're going to need some sort of extra little service or feature outside of the device to fully take advantage of these, as you'll see today, like maybe Wireshark or a NetFlow collector. But in the end, right, these are really cool features that you need to become familiar with if you want to become an amazing network analyst. Let's put it that way. All right, so we have a lot to cover today. I'm going to try to get all these demos in within an hour. And here's the deal. If something crashes, something breaks, well, that's what happens when you're doing everything live on the spot. So here we go, folks. Let's jump in right now. It's great to have each and every single one of you here. Let's start with SPAN, RSPAN, and ERSPAN. So these are tools that are essentially all the same when it comes to the end result. So the question is, what exactly are we getting out of these 3 different tools? Well, we're actually getting a packet capturing solution. That's what we're getting for our what? For our switches. So these are tools that capture packets entering or exiting a switch port. And then the device, your switch, is going to make a copy of that captured packet. It will then take the captured packet and send it to a destination that you tell it to, where you have a packet capturing service, let's say something like Wireshark, connected to. So that way there, you'll be able to analyze those packets. So I'm not going to teach you about Wireshark today, but I'll show you Wireshark, because we're going to ship what we capture off to Wireshark. But if you want to learn about Wireshark, we have other videos for that. I'm going to focus on the Cisco devices today. Now, don't forget, the original traffic, though, is still going to be forwarded to the destination. So let's take a look at this now from a switch perspective. We have our Cisco switch, for example, ASW1, an access layer switch, where we have users connected directly to that switch. We are going to have a packet capturing device connected to that same switch in this particular scenario. So what we have the ability to use now is SPAN, Switch Port Analyzer. That's what SPAN means. And SPAN specifically is going to be used when the captured traffic, so we're capturing traffic on gig 11 in this case, is going to be sent to our Wireshark device that is connected to the same switch. That's the key for this particular tool. So let's go out to our environment right now, and let's demo this. So right now on gigabit 1/4, I have connected a packet capturing device that is currently running Wireshark. Right now, it is only collecting packets that are coming to or from the actual device itself, because we haven't made any changes at all to the network infrastructure to change that behavior. So let's go over here to PC1 and PC2, or just PC1 right now. So PC1 is connected to, or going to starwinstudios.com. And so it's connected to gig 1/1. So what I want to do is I want to show you how we can capture that traffic on gigabit 1/1 and send it over to gigabit 1/4. So the first thing we're going to do is we are going to type in configure terminal, and we'll use the command monitor session, and then I have to give it a number to identify this capturing session on the device. So monitor session, I'll just use number 1 right now. And in this case, I'm going to set up the destination first. Let's set up gigabit 1/4 first. So I'm going to type in destination, and then I'll type in interface, and we'll say gigabit Ethernet, and then 1/4. Now, if we scroll up, you'll see that right now, gigabit 1/4 is a connected port in VLAN 10, right? But that's all going to change when I hit enter, because as soon as this happens, that port changes. It is now what we call a monitored port. So if we type in show interface status, you'll see it's now a monitoring port. And in reality, the VLAN doesn't matter anymore. It really doesn't, because this particular port now is designed to have traffic that is copied by the device and sent to that switch, that PC, meaning that I can't even send traffic. If I send traffic, it's not even allowed into the interface. So you can't even send and receive traffic in and out of the interface. The only traffic by default that is allowed is the captured traffic sent out that port to the device you have connected to it. So right now, if we take a peek at the Wireshark that is running, you'll see all that other stuff that was being captured is no longer there. Why? Because the port is essentially just sitting there waiting to send the captured traffic out, and I'm not capturing anything just yet. So I've converted that port into what we call a monitor port. So what you're seeing here is basically this local PC trying to find out who the default gateway is at 10.0.0.254, and it's not getting an answer. It's not getting an answer. Why? Because that port is not allowed to receive traffic anymore. So we have just set up our destination port. Let's set up the source port for capturing purposes now. We'll type in monitor session, the exact same number to match what we just configured for the destination. And now we're going to type in source, and you'll see that there's many different sources here. We're going to be focusing on the interface right now for gigabit 1/1, but you'll see that the source can actually be CPU, and then the source can actually be an entire VLAN if you want to. So you can capture traffic on any port that's in a specific VLAN and then just ship it off to that device that's connected, in our case, to gigabit 1/4. But I'll just focus here for simplicity's sakes on interface, gigabit Ethernet 1/1, and then directionality. Do I want both directions to capture traffic, or just traffic coming in, or just traffic going to gigabit 1/1, the PC connected to that? So in this case, I'm just going to say both. All right, now here we go. Here we go. Let's remind ourselves what it looks like right now on the capture device. Let's go back here. Let's hit refresh on this PC. And now let's go ahead and trigger gigabit 1/1 to be the capture port. Now that I've done that, let's go back to our capture device, and you'll see that I'm capturing everything that is coming from that PC or going to that PC. We're making a copy of it, and we're sending it over to that capture device. Now, in this case, some of that traffic is HTTP encrypted. Some of it's not encrypted. So obviously, I won't be able to decrypt the encrypted traffic unless I have the capability of doing that. But the idea here is for you to realize that if you need to monitor the traffic that's on your network, and more specifically capture packets, you can do so by taking a device, connecting it to the same switch the other device is connected to, and then set up a SPAN session to copy what you need. Now, remember, these things are typically for temporary purposes. You have a need. You want to diagnose that traffic. something doesn't seem right. So in this case, you would set it up, collect what you need, shut it off, then go analyze what you need to analyze at that point in time. Now, there was a question coming in about the fact that SPAN says we have to be on the same switch. And then they were asking, what if you have a switch stack, meaning you have stacked switches? Okay, that's an exception to the rule because a stack of switches with the stacking cables are essentially one switch when it's all said and done. So in that case, you can have the destination on a different switch as long as it's part of the exact same stack. Then SPAN will work in that particular case. All right, let me shut off this session here. So that's just a simple example of SPAN. I'll type in no monitor session number 1. Now, the key here to realize is that we have the source and destination on the same switch, right? RSPAN is when the source and destination are on different switches that are not in a stack. So with RSPAN, in this case, I can capture, let's say on DSW1, the traffic, and I can take that captured traffic, ship it across my layer 2 trunk link to my device that's connected to another port on a different switch. Now, to get this to work, you need a special RSPAN VLAN that is going to only carry the captured traffic between your switches that are in the same layer 2 infrastructure. That's the key here. We've got to be in the same layer 2 infrastructure. We can't be doing any routing whatsoever to get this to work. So RSPAN stands for Remote Switch Port Analyzer. So here's what we'll do. We'll go over ASW1. We'll type in VLAN 500. And for VLAN 500, I'm going to say you are a remote SPAN VLAN, or just remote SPAN, right? And what that does is if we look at the output of show VLAN, we'll see if we scroll down just a bit more that this is reserved as a remote SPAN VLAN now. Its specific job is to take that captured traffic, ship it across to another switch so it can be captured on that other switch. So it still shows up here, but it's specifically dedicated to remote SPAN traffic in this case. All right. So let's do the same thing now on DSW1. We'll type in VLAN 500, remote SPAN. I see a question coming in about my comment I made earlier. Is the exception to turning off SPAN after data gathering if you're using a security appliance such as Dragos or Gigamon? So here's the deal. If you want to continuously capture packets, and that is something you want to do, you don't have to shut it off. But the suggestion is if you don't need it running, you don't need to continuously capture, then the idea is shut it off. It's one less thing running, and then turn it on when you need it. But if you need it running all the time, then go ahead and do that. Go ahead and do that. All right. So now we have a remote SPAN VLAN for 500 here as well. Now what we're going to do on DSW1 is we are going to set up DSW1 to capture on gigabit 1/2 and send that captured traffic to the RSPAN VLAN. So we'll type in monitor session here, and then we will type in a number. So I'm just going to use 5 in this case because that's my choice. And our source for capturing traffic is going to be interface gigabit 1/2. And then we are going to ship that captured traffic to the RSPAN VLAN. So monitor session 5 destination. You'll see the keyword here, remote. That means remote SPAN VLAN number 500 that we created. So now we're capturing on that port. We're making a copy of it and sending it to the RSPAN VLAN of 500. Now let's type in do show monitor here, and you'll see it actually says remote source session. If it said SPAN session, it means you configured it incorrectly. And the improper configuration would be you forgetting the keyword of remote. If you forget the keyword of remote, it thinks it's a span session, so it would say span session instead. But a way to confirm that it is actually an RSPAN session is check to see if it says remote source session, and then you know you've got your source is gig 1/2 in our case, and your destination is the RSPAN VLAN of 500. Right? Question coming in, does a core switch need to have RSPAN VLAN as well? Well, here's the thing. Is your core switch actually layer 2? Typically, the core would be layer 3, using routed ports, using dynamic routing protocols like OSPF and EIGRP and different things like that. But if your core is layer 2, then and not layer 3, then yes, if you want to pass traffic from one switch through the core to somewhere else, all layer 2, then yes, you would have to do that. But if it's not all layer 2, then you can't actually use this. Remember, these switches have to be part of that same layer 2 infrastructure. You can't cross a layer 3 boundary. So every switch that is connected together, whereby you want to pass your captured traffic over, they would all have to know about the RSPAN VLAN. So that way they can encapsulate the traffic properly and send it across the trunk links. All right, so now let's go ahead on ASW1 and type in monitor session, because this is the configuration for here. Now that it arrives over the traffic across that layer 2 trunk link encapsulated in the RSPAN VLAN, monitor session. Now, this number does not have to match the other side. So I created 5 on the other side. I could use a different number here, but I'm just going to use 5 here anyways. I'm going to type in source and then remote. See, remote VLAN 500 for capturing. So I'm going to capture now on VLAN 500, and we're going to ship it to a destination port of gigabit Ethernet 1/4. Is it best practice to use a dedicated trunk for RSPAN due to the amount of traffic it capturing multiple sources? Not necessarily, because if your trunk links, you have the capacity to support the captured traffic as well as the regular traffic, then you don't need a dedicated link or connection or trunk for that. But if you don't, then it's not a bad idea. All right, so now let's go to the PC. Let's go ahead and refresh PC number 2, because this is PC number 2. So PC number 2 is at Cisco right now.com. And now we'll go back to our captured device, and you'll see we're capturing all the traffic over here on DSW1, shipping across to ASW1, and dropping it off on my packet capturing device. All right, so that is RSPAN, folks. And if you notice, or not notice, but I'll show you, do show monitor, you'll see this one says remote destination. So this one says remote source session. This one says remote destination session with a source of the VLAN. All traffic that's being shipped over that RSPAN VLAN is now being sent to gigabit 1/4. All right. So that is RSPAN. Now, one more here, and I'm not going to be demonstrating this one to you because in my lab demo environment right now, I don't have a switch that supports ERSPAN, but this is for those situations and scenarios where you are capturing on one device, but the other device you're trying to send it to is across your layer 3 infrastructure. It's across your layer 3 infrastructure. So picture it this way. You're trying to capture traffic on an access layer switch where your end users are, but this device right here is in your data center. So you go from that layer 2 environment across your layer 3 core back into a layer 2 environment in the data center where you have this device sitting. This is where ERSPAN is going to be used, right? But ERSPAN is typically only available on higher end products. So the higher end 9000 series family, the higher end 8000 series family, the Nexus product line does support it as well. Your ASRs support it. So that's typically where ERSPAN is supported. But this would be the one that you would want to use. Hey, I'm capturing over here on ASW1, but I only want to have this tool sitting in my data center. Then ERSPAN is the way to go for that. And it's a totally different configuration. It really is. It is a totally different configuration because in the end, it also creates a GRE tunnel for you. And so you have to specify the parameters for like the source and destination and all that stuff. So it's a more complicated configuration than what we just covered for SPAN and RSPAN. But if this is the solution you need to accomplish your objective, then take a look at it, folks. But here's another cool feature, and this is the EPC feature, the embedded packet capture feature. This one impresses me a lot, and the reason why is because as long as your device supports this feature, then what does that mean? It means that you can capture directly on the device, packet capture on the device, and look at the traffic on the device, and then you can even ship it off to a server somewhere, like a TFTP server or an FTP server or an HTTP server, where you can open it up on a different device. So you can capture, for example, on the router that we have here, and that's what we're going to do today, and then we'll ship it off to that Wireshark device. And this is really cool in regards to our Cisco iOS XE features. And why is it supported? It's supported this way because the newer iOS is pretty much just Linux, folks. That's what it is. And it's more Linux than anything else. So we have the opportunity to run a lot of different services and features with that you would run maybe just normally on a server. Now we can do it right inside our routers and our switches. And this is one of those examples why we can take advantage of that. All right, so let's focus on capturing right here with this embedded packet capture. So traffic coming in and out of this port, gigabit 1. Actually, we'll just do in on this port. So I don't want to crash this. This is a virtual router I'm going to be using right now to accomplish this objective. So it's a CRSR 1000V. So we want to make sure we don't overwhelm this router in this example. But we'll capture there, and then we'll ship that traffic off to there. So what traffic do I plan on capturing in this case? Well, what we're going to do is we're going to take a look here. I have an access control list set up. And the access control list I set up a little earlier, called webinar, says that we want to match any traffic from 10.0.0.0 through 10.0.0.255 going anywhere. And then any traffic going from anywhere to 10.0.0.0 through 10.0.0.255. So just by setting up this access control list, I'm now going to indicate when we do our embedded packet capture that that's the only traffic I want to capture. So how do we do this? Well, this feature is a feature you set up in privilege exec mode, not global configuration mode. And it's not even stored in your RAM or your startup config. It is essentially a temporary solution or a temporary feature that you enable for packet capturing. And then if your device ever reloads, reboots, it's gone. It's wiped. So it's just, you set it up and then it's stored. Whatever's captured is stored in a buffer in DRAM, and that's it. So it's volatile when it's all said and done. So let's first set up here. It's called monitor capture is the command. And we're going to give it a name. Let's call it webinar cap for webinar capture. And let's define the access control list. Now, I don't have to use an access control list. I could actually use the match command here. And I could say match specific types of traffic if I want to. But it's not as granular as using an access control list. So I'm going to use an access control list because with an access control list, we can match what? Source and destination IP, source ports, destination ports. We do a lot of things with an access control list. So it's a lot more granular if you use the ACL than the built-in match statement. So what was our access control list called that we created? I said it was called just simply webinar. Right, so we'll put that in there. And you can set buffer options, control plane options, other options here, but I'm just going to leave everything at their default values and we're not going to worry about it. What does it say? Capture name should be less than or equal to 8 characters. All right, fine. Let's just call it webcap. All right, so now that I've defined what we want to capture, let's go ahead and actually define what interface we're going to be capturing on. In this case, gigabit 1. So monitor capture, we called it the web cap. So we'll put that in. And now let's match our interface. And what's our interface? Our interface is gigabit Ethernet. and it's going to be gigabit Ethernet 1 on this particular device. And then what direction? Inbound, outbound, both. It's up to you. I'm just going to do inbound right now. So as traffic arrives inbound on the interface, going anywhere else. So it's coming from gigabit 1/1 as an example this way. All right, so now if I type in show monitor capture, you'll see that we have this monitor capture set up, but it hasn't been started yet. So let's type in monitor capture. We called it web cap. And let's type in start. Let's start it. So we'll start that web cap. I'm going to let it run for just a bit. You know what? Let's go over to our PCs and let's generate a little bit of traffic here. Boom. Boom. And let's go ahead and now go ahead and stop it. So now I'm going to stop it. So you can basically run it for as long or as little as you want. But like I said before, this is one of those features that you have a purpose. I need to capture traffic on this interface because there's something up and I want to inspect that traffic. That's why you're using this feature. So in this case, now, if we look at the output of show monitor capture, right, it shows us the buffer size right now and the maximum number of packets to capture. So we're starting to see some statistics here. But the cool thing is if I type in show monitor capture web cap, and then we take a look at the buffer and we take a look at brief, look at this. Woo! That's right. I can actually see that traffic. Now, you might be saying, whoop-de-doo, Raymond, nothing exciting there. Okay, well, what if we type in something like, instead of brief, we type in detail? Okay, now we're talking. Now we're getting a lot more information in this particular case. So you have the opportunity, and you can see it's encrypted traffic. That's why it looks like that. But if it was plain text, I could read that traffic. I could read the traffic if it was plain text. So the idea, though, is that you have the opportunity to capture the traffic and look at it either in a brief way or a detailed way locally on the device. But you also have the opportunity to type in something like monitor, capture, web cap, export to a destination. So let's go ahead and type in here TFTP because I have a TFTP server set up. It's at 10.0.0.40. And let's call this web cap webinar or web cap live. Web cap live. Let me move out of the way. Oh, there you go. Web cap live dot pcap. That's right. Packet capture file. And what program allows us to open PCAP files, folks? Please work. Please work. Oh, no. Oh, no. I had a feeling something like that would happen. All right. What does that mean? It means not a problem because I have an already previously exported PCAP file. Oh, actually, you know what? It looks like something's happening here. I see some being added right now. Yep. But it appears I'm having a few. I must be having, yeah. Let's try one more time. All right, so I'm not going to fight with this and troubleshoot this connection I have to my TFTP server right now. It was working a while ago, trust me, before class, so something's up right now. But that's okay, because what I'll do is I'll open one of the PCAP files I recorded yesterday, and you'll see here that this one here, 113 kilobytes right now, just a small little PCAP file, but I can open that now in what? In Wireshark, and this is what I captured. So that's an example of what you can capture on the router and then export it to your TFTP server, HTTPS server, whatever server you have, where what? You can then use Wireshark on any other machine you want and connect to that folder on that server and look at your PCAP files. So you don't even have to log into the server that has a TFTP or HTTP or any other storage for you. You can do it right from your local desktop using Wireshark, connect to and open the PCAP file wherever it is. And so, great little tool, awesome little tool, allowing you to capture that traffic as it's flowing through those iOS routers. and shipping those off to a storage location and then opening it up in Wireshark. So embedded packet capture. All right, so oftentimes people now confuse the difference between something like SPAN, RSPAN, ERSPAN, and embedded packet capture. Why? Because NetFlow, sometimes in documentation, when not documented properly, says that it's a packet capturing tool. Well, I have just shown you a true set of packet capturing tools with SPAN, RSPAN, ERSPAN, and embedded packet capture. Those are true packet capture tools, as you've seen. NetFlow's not, right? The thought process I want you to have with NetFlow is that this is a tool that allows you to gather traffic statistics. That's the best way to look at it. And then those traffic statistics can be used for many different reasons. For example, you could use those traffic statistics to identify how much some device or some user has used a part of your network, and therefore maybe you charge them, and that is for billing purposes. You can identify traffic on your network based on the statistics that are gathered and identify maybe anomalous traffic, and therefore you have a security problem potentially in your environment. You can use NetFlow to keep track of the performance of your network and a whole lot of other options that are available to you. So what I want you to realize about NetFlow is that we are going to be using it to keep an eye on traffic that is flowing, but not actually capturing it. And so we need to understand what a flow actually is when it comes to something like NetFlow. A flow is traditionally, and I use the word traditionally because it has changed recently with a new version of NetFlow, but traditionally it is what? It's going to be unidirectional traffic. So when we say unidirectional traffic, traffic going one way, right? So traffic going one way, unidirectional, and it's going one way from to the same source IP, the same destination IP, the same source port, the same destination port, the same layer 3 protocols being used, same type of service markings, and it's arriving in on that same input logical interface, for example, like you see here. So I'm capturing a flow of traffic, and a flow is anything that matches this values here. So if any one of these values are slightly different, just a little bit, then it's part of a different flow. So one PC does not mean everything they send is a flow. Because if I have a PC going from a source to one destination and it's the same source going to a different destination, that's two different flows. Or if it's the same source and destination for both those flows, but different port numbers, then those are different flows. So if any of these are slightly different, then that's a totally different flow, and you would analyze that as a totally different flow. So in that particular case, you'll know where the traffic's coming from, where it's going to, what's the ports, and this and that. And then based on that information, you can use it for a multitude of different purposes like we talked about before. But you're not actually capturing packets to analyze the packets themselves. Flexible NetFlow is the new version of NetFlow. Flexible NetFlow allows you to control what is considered part of a flow and what information you collect about that particular flow. So the old NetFlow was only this. This is all you had. These 7 values, nothing more, nothing less. It was always these. But with flexible NetFlow, the name says you have flexibility in deciding what you want to capture and what defines your flows. You get to control all of that nowadays. So you have what are called flow records, whereby you define what you capture. These can be predefined flow records that Cisco has already set up on that item, on that device. So for example, those original 7, you can use a command that'll automatically use that predefined original 7, as well as some other ones that Cisco has predefined, or you just create your own. You create what is called a flow record, and you say, this is what I want to define my flow, and these are all the values I want to capture for traffic analysis purposes. And then you have a flow monitor, and that flow monitor is just you defining what interface you're going to be capturing on, and then what you're going to be capturing based on the flow records you created and defined, and then who you export the traffic to. Now, you don't have to export it, but NetFlow's really not very valuable if you don't have a server to export it to, because in most cases, by default, the information you collect is not going to be on that device very long. Maximum 30 minutes by default, maximum. And if you have a lot of traffic statistics you're gathering, then it could be even less than that, as it uses heuristics analysis to decide what to delete to make room for the new stuff. So by exporting it, though, at least you're sending it to a place for long-term storage, because there's really not a lot of storage space on your device. So NetFlow works best with a NetFlow collector. So you're going to have to set up your flow exporter. And so your flow exporter is going to be that server. So you got to teach your router, train your router on who that is. And so you can export all that traffic to it. And to improve the performance of the device, you can also create what is called a flow sampler. And a flow sampler is just you telling your router, hey, instead of collecting statistics about every packet, how about you collect statistics on every 100th packet, or every 200th packet, or every 50th packet. So that way there, over a long period of time, I still get a good sampling of what my traffic's like. I'm just not analyzing every single packet that's arriving at the device. So once you have that all set up, you'll see here that I have a flow monitor set up, and I've been able to gather, collect information. In this case, my flow record wasn't all 7 of them. It was just 4. Capture the source IP, the destination IP, the application that's being utilized, and the interface that it was inputted on. So just a simple user-defined one, just to give you an example here of NetFlow. And I'm looking at the flow cache right now on the device, and you can see that 15 seconds of inactivity means that the information that is collected will be deleted. That's what that means. So if you don't have an exporter set up, 15 seconds is potentially all that the information will be in your flow cache for. If the session is still active, then it can stay in there for up to 30 minutes when it's all said and done. But you'll see what we have collected here. Now, I'm going to go out right now to SolarWinds. I'm not promoting SolarWinds, all right, but most of you are familiar with SolarWinds. Well, they have what is called a NetFlow collector. And so with a NetFlow collector, I have a server set up running SolarWinds NetFlow collector software, or any other company that's out there. But this is where the power comes in. You see, on the device, this is not very valuable. But over here, this can become super valuable, especially when you have anomalies in your traffic and you can quickly identify the traffic that's causing the problems for you. And then you can ultimately dive into action, identify the traffic that is consuming a lot of bandwidth, and eliminate it if you have to, especially if it's not traffic that should be on your network. So as you can see, there's a whole lot of different things you can do with NetFlow, but the power really comes into collecting that traffic and then having a tool that's going to give you the opportunity to analyze that traffic very, very efficiently and very effectively. All right, so now I want to talk about Embedded Event Manager. This is a really amazing feature that many people don't even know exists. And what is it? What is it? This is about automation. That's what it is. Embedded Event Manager is purely about automation. It's an embedded feature that allows you to automate things on your Cisco device. You create what are called EEM policies, and you can do that using applets. I'll show you that today, using the command line interface. And you can also use what are called what? Scripts, using TCL, tool command language. I won't be doing that today. But here's the gist of it. What you do is you define the event that's going to trigger your automated actions. Let me repeat that. You define the events that are going to trigger your automated actions that you specify. So what are some of the events that could be detected with EEM? Well, here's a large list. Application-specific events, CLI events, syslog events, IPSLA events, SNMP events, timer events, and you can even manually trigger events on your own if you want to. And then what about the actions? So when an event is detected, an action will ultimately take place. at that particular point in time. And then the actions could be an automated CLI command that runs. It could be even your device sending an email. It could be triggering another EEM policy. It could be sending an SNMP trap. Could be sending a syslog message. Could just be generating and printing text right on the screen. So let's go ahead and show you this in action right now on R2 in this environment here. I have this pre-defined in a notepad file, this little example here, so you don't have to watch me type all of this out. But you can see here that I'm creating this event manager applet. I'm giving it a name. I am saying, in this case, that if the event is a specific syslog pattern that is generated, and this is the specific syslog pattern, gigabit Ethernet 0/1, change state to administrator. If that shows up behind the scenes, it doesn't even have to be on the screen, behind the scenes by the device, then I want you to perform these actions. Create a syslog message telling me that you are re-enabling the interface because it's been administratively shut down, and then execute this command, this command, this command, no shut, and then we are done. All right, let's go ahead and do that right now. Copy that, paste that in, hit enter, hit update. All right, here we go. All right, so now we'll go to interface gigabit Ethernet 0/1. Let's type in shut it down and watch what happens. An automated built-in feature. All right, so the interface has gone down. The EM applet has just been triggered. It says, oh my gosh, it's been down. So interface gig has been administratively shut down. We're re-enabling. Boom, interface is back up. Automation built right in to your Cisco platform. All right, look at this next example here. In this case, I'm saying if the syslog pattern this shows up, then let us know that the interface has been restored and send an email to who? emapplets@stormwindlive.com or from emapplets@stormwindlive.com, which doesn't exist, by the way, folks. Don't try and spam that, all right? And IT team at stormwindlive.com, that doesn't exist either. Don't try and spam that. You're not going to get anything out of it, all right? So let's go ahead and show you that in action now, but you'll see how the results of the first applet are going to trigger that. And then in the end, this one's going to get triggered. So it's going to be one after the other that's going to get triggered in this particular example. All right, so we'll exit out of there, paste all of that in. And now let's go to interface gigabit 0/1. We'll shut it down. This example is like a candle that can't be blown out. Exactly. That's a good analogy. Eddie, thank you so much for that. That is awesome. All right, so now you'll see here that in the end, we went through that whole process where we shut it down. So the first EEM applet got triggered, and then it re-enabled the interface. And then once it went back up, we got a message generated that says, hey, interface gig 0/1 has been restored, and now it's trying to send an email. Now, I don't have an email server set up for that address, so we're going to get an error message, and that error message proves that the email is actually trying to be sent. There it is. It's actually trying to send an email to that SMTP server at 10.0.3.8. And then lastly, here's a little extra in the end. You can even manually trigger your EEM applets. So in this case, notice the event is none. What does that mean? It means I manually trigger this. And in this case, it's when I manually trigger this, it's going to do these actions, generate a syslog message that says my example manual policy has been triggered. It's going to go enable, configure terminal, interface gig 0/1, shut down, end. And then it's going to also put a message on the screen. So not a syslog message, just a message, which means it's not going to end up going to a syslog server, just a message to let us know that gig 0/1 has been disabled because someone ran the manual policy. So I'm going to put this one in now, just to show you how you can automate pretty much anything if you know the commands when it's all said and done. So that one's all done. So now I'm going to go ahead and execute that manual policy. And the command to do that is going to be event manager run. So event manager run. And it is in privilege exec mode. Forgot about that. So event manager run. And then what is the name? Let's run it. And so what does this do? This one will shut it down, which then, and there's that message. And then you'll just see that every single automated action is going to happen now. So yes, as Eddie had said, this is a candle that just won't go out. And there you go, folks. That's an example of EM. So just as you saw earlier, based on my slide, there are tons and tons and tons of events that could ultimately be utilized. Even timers, if such and such a time gets met, do this. You could have this automatically save your configuration once a day, or do something once a day, twice a day, 3 times a day. Like there's just, it's just, the list of things you can do is just phenomenal. And then the actions. So many actions that you can take. Now, there was a question about the CLI actions. When initiating the CLI command enable, does it still pass the login credentials? So what you need to realize is that when you're doing EEMs, when you build those EEMs, they are running at the highest privilege level when it's all said and done. That's what's going to be happening anyways. So you just list all the commands you need to type in, and it's going to execute those commands anyways with the highest privilege level. So yeah, you don't even need the enable password if that's what you're wondering in order to get into the device. It's not something that you need. It basically bypasses all of that because you would have had to have the right privilege levels to create these EEM policies anyways. So because you were able to create them, because you were able to put them in, therefore it's just executing them as such behind the scenes. You can automate port descriptions when another device is connected? Absolutely. Absolutely. Can you monitor a MAC address to be on a port? Well, the thing is that you would have to find the event that allows you to learn or see that particular MAC addresses that are on a particular port, right? So, and there's a lot of other, there's tons and tons and tons of tools that you can utilize to do that. So it's about creating an event that has the ability to see that MAC address based on however you want to do that, and then be able to execute if it sees that particular MAC address. So basically your limitation is what you're capable of imagining when it's all said and done. All right, and finally, with our time remaining, we're going to take a look at IPSLA, folks. So IPSLA, another really great feature that a lot of people don't take advantage of, and when they learn about it, they're like, maybe we should be using that. So with IPSLA, another tool built into Cisco iOS, and this is about continuous monitoring and measuring of a multitude of different aspects of your network. So anytime you're trying to figure out, hey, how do we keep track of that? For example, how do I keep track of jitter? How do I keep track of packet loss? How do I keep track of delay? How do I keep track of just basic connectivity? IPSLA is your answer. And IPSLA can do so much stuff. It's basically, it could be a course on its own. But the end result is that if you want to identify if a particular destination is reachable, and if not, use a backup path, IPSLA can help you do that. If you want to know if your service provider is actually giving you the bandwidth, the delay, the jitter, the packet loss, everything else that goes along with that for the MPLS network you're paying for, IPSLA can help you with that. If you just want to measure your own internal network performance statistics, so that way that you know how your traffic, like a voice packet, potentially is being treated or being prevented from reaching its destination in the efficient time possible, right? You need to know what the performance is in that part of your network where the voice packets are flowing. Again, you could do that here with IPSLA. So why use IPSLA? Many different reasons. It can help you increase productivity, lower operating costs, reduce the frequency of network outages, helps you troubleshoot, helps you identify problems and analyze those problems. It even helps you design networks. Why? Because if you set up IPSLA and you monitor that environment and you realize it's not that efficient, then it can help you redesign your networks when it's all said and done. What does it use? It uses, folks, active traffic monitoring. That's what it uses. Active traffic monitoring. Basically, you're sending a probe in a continuous, reliable, predictable manner. And then you can collect the results locally within memory on the device. or you can store it in an SNMP, management information-based variable, and then have the SNMP server collect that information at the polling interval. So I'm going to show you an example here of using IPSLA for floating static default routes. So in my particular setup here, folks, we have a primary connection to our service provider, and we have a backup connection to our ISP. That's what we have. If we look right now on our device for router number 2, and we type in show IP route, we're going to see that the primary entry is currently, primary default or static route is in our routing table. If we look at the configuration, show run pipe to include IP route, we're going to see here that I actually have 2 default routes, one going this way and the other one going on the backup link. Why is that one in the routing table? Can anybody tell me why this one's in the routing table and the other one's not in the routing table? What's the key word? Anybody who's been studying CCNA, who's preparing for an exam, should know this answer. I'm not calling anyone out, but you should know. What is the reason why? That one's in the table, but that one's not in the table. Okay? It's not metric. It's a different word I'm looking for. Starts with an A. Administrative distance. Thank you, Chris. Yeah, administrative distance, AD for short. This route has an administrative distance of 1, and this route has an administrative distance of 2, so it's not as trustworthy, not as believable. All right? Here's the deal. What you need to realize is that your static default route goes in the routing table if the next hop IP address is reachable. How is that next hop IP address reachable? Through another interface on the device. In this case, I can reach that next hop IP address through, there you go, there's my full routing table, through this interface right here, because that 203.01.13.88/29, that IP address is in that particular network. Here's the thing though. Your interface status, up versus up down versus down down, right? That is all based on what? Your layer 1/layer 2 connection. What does that mean? It means that if this interface goes down, then that gets removed from the table, and the other route is going to get installed in my table. But when you look at this diagram, folks, am I really going to be directly connected to my ISP in most cases? No, I'm not. Why? Because there is going to be other layer 1 potentially and layer 2 devices, layer 1/layer 2 devices in between. So what does that mean? It means that if we have a failure from here to here, then this is going to go down, right? That'll go down. And therefore, the static route would be removed from the table and the other route would go in because it's still, that one's available now. Okay, but what if the failure happened here or here? Well, this is still going to be up. If that is still up, then this is still in the table, which means traffic is going to be dropped because it can't get through. It can't get through. So IPSLA is going to help me overcome this problem. By what? Tracking the link all the way through to the end. So for example here, let's do a quick configuration. I'm going to say IPSLA, and I'll set up an IPSLA instance right now. We'll call it instance number 1 in this example. And I'll type in ICMP. I'm going to use a ping packet here, folks. That's right. I'm generating my probe, a ping packet. Let's ping 8.8.8.8. Oh, don't have my numlock on. There you go. That's not good. Let's go back here. Okay, ICMP echo. We'll type in 8.8.8.8 is my destination. And from what interface, what IP? I'm going to do source IP. And we're going to say the IP address of my interface right here. So, and how often am I going to do this? Let's say every 5 seconds. All right, we'll exit out of here. Now I'm going to start this. And in this example, I want it to start now and last forever. That's what I want to do. So IPSLA, schedule it. And you'll see that your schedule for that SLA instance of 1, can have age out times, lifetimes, recurring times, and all of that. But I'm going to type in start time in this example. I'm going to say I want it to start now, and I want it to last forever. Right? So now this is running. So if I type in IP or show IP SLA statistics, you're going to see here that it's okay. It's working. I'm getting my ping. I'm getting my ping. I'm going to go to my ISP right now, and I'm just going to bring down interface VLAN 1 in this case, and this is part of my scenario. Just going to type in shutdown, and what you're going to see here momentarily, that the ping is going to fail to reach the server. It's going to fail to reach the server. And as a result of that, you see how it says timeout. So this is all IPSLA is doing in this case. It's just keeping track of that ping. Is it working or is it not? Nothing more. It's not even fancy, right? It's just a simple probe to diagnose connectivity here. Is it working or is it not? So let me bring it back up. And now that we have it back up, what we're going to do is we're going to see that it's going to come back up and it's going to start saying okay again. Right. So what we're going to do is we're going to attach this probe now to our static route. So that way there, if this ever fails, this connection anywhere along the line, anywhere, to get out to the internet, what's going to happen is that this times out and the static route is going to get removed from our table. But if you look at our static routes and you type in, I'll just type in quickly here, IP route 0000, next top IP address. I'm just going to put in 000 for right now. You're going to see that I don't have the ability to directly attach IPSLA to my static route. I don't. But what do I have the ability to attach? What is called a tracking object. This is a cool little feature here. So what we're going to do is we're going to set up a tracking object first. And the tracking object, I'll give it a number. I'm going to call it number 5 in this case. We're going to track, you can see interfaces, IP, IPv6, a lot of different things, but I'm going to type in IP, and then look, we can track IPSLA. So typically IPSLA and tracking objects go together quite often in a lot of different scenarios you're going to use them in. And then what is that SLA instance we created? It was called SLA instance number 1. So we'll put that in there. And let me just back up here. I didn't mean to hit enter. And then what do I want to check? I just want to track the state of it. The state of it. That's it. Are you up? Meaning, is the IPSLA working or not working? That's it. That's all I want to check. Nothing more. All right. So now that I've done that, when the SLA instance goes down, the tracking object goes down. So if the SLA instance goes down, the tracking object goes down. Pipe 2 section IP route. Watch this. We are going to attach it to our static route now. So the thing about static routes is you actually have to remove them if you want to reconfigure them on your device. So I'll take that off. Now what we're going to do is we're going to put it back on. But in this case, we're going to attach our tracking object to it. And we call it tracking object number 5. So all this means now is that if this tracking object goes down because the probe fails, then we get to remove that from our table. And then because that's removed from the table, this one then gets installed. So do show IP route. You're going to see here right now that this is the one installed. So let's go ahead and bring down that interface, because that is going to cause the ping to fail. The ping fails. That is going to trigger the IPSLA instance to then fail, which then means the tracking object goes down, which then means that route gets removed from the routing table and the backup route gets installed in the routing table. So there's an example of being able to use IPSLA to track something that is going on somewhere else and then have your router change its behavior based on that probe not working or that probe failing. Let's type in no shut here, bring that back up, and you'll see that once it comes back up, because the interface is up, the IPSLA instance starts to work. Therefore, the tracking object goes up. Therefore, what? We install the old route back in the table. All right, great little feature. And it's a feature you definitely want to take advantage of for your static default routing. If you have multiple connections to different service providers, even the same one, it's a really good tool feature to have. Right? In this case, what we want to realize is that this router was a Cisco device because this is a Cisco specific feature, but the destination was not, right? The destination was what? An IP address of 8.8.8.8. So in that particular case, it was a very easy setup. Now, there are situations and scenarios where you absolutely want to have what is called a responder. So in this particular case, I've set up what is called a UDP jitter. Now, in this case, what I'm doing is I'm mimicking, not fully, okay? I didn't go into the full configuration, but I'm mimicking a voice packet. That's what I'm mimicking in this case. And by using UDP jitter, I can keep track of things like round trip times, as well as one-way delay, one-way latency, one-way jitter, all of that stuff. But the device on the other side has to be a Cisco router or a Cisco device that understands IPSLA, right? If that's the case, you can accomplish this. And take a look at the results in this case. I have round trip times now between router 2 and my branch router over the WAN, and it's showing me round trip times, but then look, it's showing me latency, one-way latency measurements, one-way jitter measurements, packet loss values. What does that mean for you? In this scenario, it's going to give you the opportunity to keep track of the performance of that connection. And therefore, you'll know if you're getting exactly what you're paying for from your service provider. But the idea here is that your probes, you want to create so they mimic your traffic. So in this case, when you set up your IPSLA probe, you'd want it to look like, feel like, smell like, taste like a voice packet. And if you wanted to create a probe on another type of traffic, then you want to set it up so it mimics that traffic. So you'll want to set the packet size for that probe. You'll want to make sure that you send the probe at a regular interval that makes sense for that type of traffic. So you get true statistics when it comes to that. So that's what IPSLA is doing. It's allowing you to create fake traffic on your network that mimics other traffic so you can gather statistics for statistical analysis, performance analysis, and so on and so forth. Or you can even use it like we saw with our default route one to keep track of a connection, keep track of a service, keep track of a server. And if something happens to it, have another service or feature that can be integrated with IPSLA and tracking objects, fail over, change its mind. For example, with something like HSRP, if you use HSRP, you can totally use IPSLA and tracking objects to change who the default gateway is based on something that is happening further on down the stream in your environment, folks. So with that said, folks, I hope you absolutely enjoyed today's webinar on SPAN, RSPAN, ERSPAN, embedded packet capture, NetFlow, EEM, IPSLA. Hope you enjoyed those demos that I was able to share with you. Obviously, there's a lot more involved for each and every single one of these services. So today was pretty much a crash course in all 5 of those. And if you like what you saw and you want more, take a look at what we have to offer here, folks, at Stormwind Studios. Our catalog, of course, it just keeps increasing all the time. We have AI courses, cybersecurity courses, ITIL, PMP, full stack developer courses, folks. So tell all your developer friends to come check us out because we've got a full stack of developer courses for all of that as well now. It's not just about networking and servers anymore here, developers as well. So spread the word, let everybody know they have development opportunities here as well. If you are preparing for an exam and labs are needed to prepare for them, we've got you covered there. We got practice exam. We got a multitude of other study resources to help you out. So check us out, folks. Call in. We'll put in a link for us right now. Check out that link you see there, partners.stormwind.com. Next step, webinar in the chat area. Click on that or take a screenshot, copy this down. Wait, let me get in position. There you go. There's your screenshot. Or reach out to Mike Fajan. So that way there you can get your needs taken care of. All right, folks. So we are past the top of the hour. Thank you for hanging out with me just a little bit longer and let me wrap up that little demo I provided to you. But, all right, we'd like to see you here taking advantage of everything we have to offer, because remember, we're here for each and every single one of you. So keep on learning, keep on training, keep on making yourself more valuable, and let us be part of that journey for you. Thank you very much, folks. Have a wonderful rest of your day and weekend when it arrives, and we'll see you here in a future session with us.